Assalamu alaikum. I'm Dr. To. This is data structure subject, chapter 4, stack. Okay, what is a stack? It is a data structure in which addition of a new elements or deletion of existing element takes place at the same end. What does this mean? This is like inside here. This is like inside the cylinder or bucket. So you are going to put inside here one by one. Okay, so this is called push. Push means that you are going to put one by one inside here. For example, you will put number 1, after that number 2, number 3, number 4, number 5, and number 6, like this. You will put it one by one here. So whatever you put the first time, it is going to be in the inside here. Then after that, this is the second time you put. Then the last one you put will be on the top. Okay, so when they are going to remove, they will remove from the top one first, because the top one is the last one you put it. Then when they are going to remove, pop means that they will take it from here, or they will delete it from here. Okay, so they will delete the last one, not the first one, because the first one is inside the down now. Okay, so this is called the stack. It is like that. This is like the cylinder or basket inside here. Okay, so this is a close at the end here. So you are going to put it one by one. You are going to add one by one. So the first one you put, it is going to be in the inside here, the down one. Then after that, next one. The last one will be on the top. So when you are going to remove, you will remove the last one, you put it here. This is called the pop. So we are going to use two words here. Push means that you are inserting. Addition, you are adding one by one. Pop means that you are deleting or you are removing one by one. Okay, so it means that when you put here, the first one is going to be in the last. Okay, when you are going to take out the last one, because the last one is on the top, so the last one will be going out first. So that's why this is called the stack works on LIFO. LIFO means last in, first out, because this is the last one you put it inside here. For example, here you have a number 6 here. Okay, but when you are going to take out, this number 6 will be going out first. So that's why this is the last in. This is the last in, but first out. The first time it is going to out. This is called LIFO. Last in, first out. What is the last you enter, it will go out first. This is the stack here. So we are going to use the push and pop. Push means that we are inserting or adding the element inside here. Pop means that this is inserting or adding is the same thing. Pop means that you are removing or deleting. You will take out one by one, okay, from here. Okay, top is, you already know which one is the top here. You will be removing the top from here. The pick is like that, copy the top one without the removing is. But when we write the program, we will be using this push and pop. Push means that we will put or adding inside here. Pop means that we are going to remove or delete, or we will take out from here one by. Okay, so basically the stack means that you are going to put inside inside the box here. So, and here it is closed. So when you are going to put inside here, whatever you put, the first one is going to be inside here. Okay, then after the next one you put, then whatever the last one is here, it is going to be in the top. So when they are going to remove or take one by one, okay, they will take out the one on the top here. Okay, so top one is the last one you enter here. So when you take out this, the last one you enter will be taking out here. So for example, inside here, you are going to enter or insert, push. So this is the first one you enter here. Then this is the second one, third one. But when they are going to take it out, they will take out this one first, because this is in the top here. You enter the last one, but it is in the top. So when they are take out, the number 1 is going to come out first. After that, number 2. After that, number 3 will be the last one. So that's why they call this is last in, first out. Okay, look at the simple program. This is here. Write a C++ program to push and pop. We already know just now, I explained push means that you are adding or inserting inside the box. Okay, and then this is the pop. Pop means that you will take out or remove or delete from the box or whatever it is. Okay, and an element and a stack of 4. Okay, so there are 4. You are going to insert the 4 numbers. Okay, for example, here this is one of the example. Okay, you are entering the 4 value here. 1, 2, 3, 4. This is the first one. This is second, third, and fourth here. The first one you enter is 11 here. So this is like inside the box. Okay, sorry, inside the box. The first one you enter is here. Then after that, the second one you enter 12. This is the third one. And then this is the last one you enter is number 14. That's why this is the stack after the push operation. So it means that after inserting, the first one you enter is inside here. Because when the program is run, only this one is coming, enter value. So you enter the 11 first. So 11 will be on the down here. And after that 12 you enter. After that you enter 13. After that you enter 14. So 14 is on the top now. So this is the after push operation, it is going to be like the inside. 11 will be on there and inside there. So top on the top is 14. So when they are going to pop, meaning that when they are going to take out from here, the 14 will go first. So that's why here they say the 14 is going first. It is opposite like this. 14 is going first. After that 13 will go. After that 12 will go, and then after that 11 will go. This is the pop operation. Okay, this is going fast because this is on the top, so this is a going fast like this. So and here we already know we have a IO include IO stream using namespace std, but here we have to define the maximum because we have a stack of 4 here. Okay, because of the 4 here, we have a maximum is 4. We have to include here define. Okay, because otherwise it will be keep on coming enter value. So you have to define here how many you want maximum. Maximum will be the 4 here. Okay, 4 value you are going to enter. Okay, then this integer main and this one, these are the heading part here. Okay, so now here because this is a stack program, so that's why we have to declare the stack here. This is the integer the number we are going to enter. So integer stack is a maximum. Maximum we already declare here 4 here. Okay, so the I is always start from 0 here. Okay, we already know when it is start from 0 and it is going to be less than maximum because 0, 1, 2, 3. So it is already 4 elements. Okay, so that's why we have to be less than maximum and then I++. Then after that, when you run this program, the first thing coming out is an enter value. Program asks you to enter the value here. Okay, so you already know what is this. This /t is the tab here, space here. So this is it. The first value you enter is 11. Then after that 12 and this and that. Okay, because you enter the 4 number. After 4 number, automatically this result is coming. Okay. After that, they will say stack after push operation. So it means that after you insert 4 numbers, then they will give like this. This is the push operation. Push means that you are putting inside the box or something like this. Okay, so after that you have to, okay, so this is for this one. Okay, I equal to maximum minus 1. Okay, so it means that this is like maximum is 4, 4 minus 1, I greater than or 0, 0, and then I minus minus. So you have to make sure that this is there. I minus minus is going to be there and here. Okay, after that you have a stack I. Then after port operation, it is going to be I equal to 0, I less than maximum and I++. You will take back this one, the same thing here. The same thing, the first one, whatever you declare, you will be taking out here. Only this thing is the different because you are going to make a pop and push operation, that's why. Okay, so this is the opposite you write it usually before you write here like I equal to 0, but and here you have I equal to minus maximum minus 1, I greater than or equal to 0, and then I minus minus. Okay, And here, you have the same thing, you write from here. Okay, after the stack operation, and then you get this one. Okay, so let's run. I will show you in the online C++ compiler. Okay, so this is the program just now. You can write the return 0 here, no problem. Okay, and here if you don't write also no problem. So when you run this program, this is from the slides. Okay, so the first thing is coming out is the enter value here. This is a C out. We already know in the C++ programs, this is a C out, and then we have to enter C in. We have to enter the value. Okay. See, the first thing is only just a enter the value. So because we declare here is the maximum is 4, we have to enter the 4 number. So when you enter the number, you can enter 1, 2, 3, 4. Or in the example, there is 11, 12, no problem. You can enter even the 100, 200, 300, no problem. Okay, so now here I will show you with 100. Oh, okay, 100. Okay, and after that, enter, and 200, enter, 300, enter. See, you have to know that 100 I enter first. So, and the bounce 100 will be in the down place. Okay, 400. So this is the 4 numbers because we define the maximum 4 here. Okay, so enter. Then the rest of the result, they will put it automatically. See, this is the things is coming. You need to enter only the 4 numbers. Then this 4 number, after you enter, this is stack after push operation because you enter the 100 first, so 100 is in the down here. Okay, then after the 200 and then 400 is on the top. So after pop, when they are going to take out, they will take out the 400 first. Okay, then after that 300 and so. Okay, they will take out because they put it on the down first because when they are taking out the 400 first. Okay, so please try to understand this. Okay, and the final, it will ask you change with something. Okay, so and the result will be given. Okay, but the result might be different here. Okay, so you have to change in the program. Okay, based on the result. So please try to understand. Okay, let's go back to the slides. Okay, so this is chapter 4 is finished. I have only 2 slides. This is an explanation and then this is a simple program. Okay, so because we all know that this semester is very short, I'm not giving you many things. So just try to understand this. Okay, and the final exam, okay, you will get the output with a little bit modification. So you have to know where to change here. Okay, so let's go here for the chapter 5. Okay, chapter 5 also I have only 2 slides. Okay, one is for explanation and another one is for simple program. So look at here, this is a queue. Queue is opposite of the stack. Okay, because stack means that in the stack, inside the box, you put it one by one. So the last one on the top will taking away. Okay, but the queue is different. Queue is like, for example, in the restaurants, when you are going to eat and then you line up one by one. Okay, so and here, the first one, for example, you are the first one, then you will be moving fast. This is called the front. After that, adding will be at the back. Okay, one by one. Then this is next, and then adding will be at the end here. Okay, so when removing, the first one is removing first. The first one will go out faster. After that, next one. So the last one will be the last. So it is called fast in, fast out. Okay, so queue is fast in, fast out. So stack and queue are opposite. Okay, so that's why what is a queue mean? Queue is the addition of a new element. Adding, when somebody is adding or new person is coming, it is going to be at the back. Rear means the back, at end. Okay, so you cannot come and cross here. It must be, you must be lined up at the end. So that's why addition of a new elements take place at the end or called rare. So this N is also called rare here, R-E-A-R, rare. Okay, deletion. When it is deletion or removing, okay, it is taking away from the from. Deletion take place at the other end. It is called the from. Okay, so the from will be deleting or removing first. Okay, so that's why this is a Q work on the FIFO. FIFO means fast in, fast out principle. Okay, so this is the opposite of the stack. So, and here they use the different thing. This is the same thing, push and pop. And here they say that it is NQ at the element at the end. They adding at the end here. Okay, when the new element is coming at the end, they add it. And it's also called the rare. DQ is take element or take an element from the front line. So it is like that when removing, it will be removing from the front line. So this is the same like a push and pop. Okay, so now I'm going to show the pick is also, this is just a copy. Okay, so we are going to use the push and pop. Okay, for the simple program. The next one, look at here. This is the program is a little bit different, but it is a simple. This is the output is given like a C++ program to print and remove. So it means that you are going to print or you are going to displace first and remove all the elements of the queue. Okay, so it means that you are going to print first and then you will remove all, because it doesn't, the program, and here this program inside you automatically enter the value here. Okay, so when you run this program, this result is automatically coming. They are not going to ask you enter the value, because inside here the value is already entered. Okay, so that's why this is like going to display the result, or just to print or to display the same thing. After that, you are going to remove all these things. Okay, all the elements of the queue. Okay, so and here, okay, we have a IO string using namespace, and here before in the first program we have like a define maximum is 4 here. Okay, but now here we have a different thing. We have to put as a queue here, include queue. Okay, so this is one of the things that you have to know for the queue. Okay, so here include IO string using namespace std, integer min, and this open. These are the heading part we already know, but and here we have include queue. Okay, so and here queue integer, because we have a here integer, we are going to enter 5 integer, 1, 2, 3, 4, 5. Okay, and then this is the queue. This is the declaration of the empty queue here. So what we are going to put, we already know push means that we are going to inside, put it going to be inside. So the first one is 10 here. The first number will be 10. Then after that, 20, 30, 40, 50. So 10 is the first coming, so it is lining up in the first. Then after that, next will be 20, 30, and then 50 will be at the end. It's called the rare. Okay, it is going to be like this here. Queue elements are 10, 20, 30, 40, 50. You enter the 10 first here. Okay, so this is how you enter or insert it inside the queue. So these are the C out. We already know in the C++ program, C out is the output. Is these outputs are coming here. These are only the declaration. Declaration, okay. Declare the empty queue. After that, you are inserting inside the queue. So what is the output you want? The first output is a queue size. How many size you enter here? You know 1, 2, 3, 4, 5. You enter the 5. So you have to know how to find the size here. Then this is called Q is from here. Size. This is the formula you have to know. Q size. So it means that Q size is a 5 because you enter the 5 integer here. 1, 2, 3, 4, 5. Okay. So after that, this is the from element. From element is means that which one is the first in the line. So this is the Q from. So the first is a 10 because you enter the first 10. 10 is waiting in the first line. Okay, how about the rare element? Rare element is at the end or the back element. This is called Q back. It is at the end. So the back elements, we already know that the last one is the 15. Okay, so the from is the first one, rare or end or back is the last one. Okay, so we use this one. You have to know size, front and back. So these are the, okay, the formula. Using formula, they give the answer here. How about the next one here? Q elements. So it means that they want to bring everything. Okay, so they are going to bring everything starting from 10, 20, 40. So that's why they say that you have to write these things. Because the question here say that you have to bring all the elements first, then after that you have to remove. So that's why we already know here we have a pop. Pop means that we are going to delete everything. After printing, we are going to delete everything. So it means that while Q is empty. Okay, so this is like empty means that after printing everything, they are going to empty. Okay, Q will be empty. Okay, this is the tab here. Okay, and here the tab is inside here. The tab, when you use the tab, it may be there, the space will be a little bit bigger. Okay, this is a Q from here. So to pop, you already know the push is mean the inserting. Pop means that you are deleting or removing. After that, after this place, okay, you will be removed. This is a pop. Okay, so now after this sentence, okay, when you say the Q size after printing the elements, when you, okay, go for the Q size now, it is going to be 0. Before Q size is 5. Here, see, these are the same comment, Q size. But and here also Q size. But the answer is different. Because and here, it is not removed here. But and here, this part, Q pop, it means that you are removing, you remove everything already. Okay? So that's why here, Q sign after printing the elements. So it means that these are the printing. Okay, after they print all the elements, then there is a no empty because they already deleted here. They already deleted. Okay, so that's why now the Q sign is 0. Before Q sign is 5, but now Q sign is 0. Okay, so these are the simple, okay, I mean the coding you have to know, okay, how you are going to, okay, find how you have to write the coding for the size of the Q, okay, when you want to know the front, back, or if you want to bring all the elements in the Q, and then after that, okay, after printing, how about the size? Okay, there will be the empty 0 size. Okay, so again, this is the basic things. Okay, please try to understand. It might come in the final also. Okay, because at the end of chapter 4, chapter 5, only we have I gave you only one simple example. Okay, so the answer will be the different here. So based on the answer, you try to change it into here. Okay, let's go for this one. Let's go and run in the C++ compiler. Okay, so this is the program. Okay, Q program. Okay, so when you run, okay, we don't have to enter anything because everything is already in the program. So we are just going to bring whatever. Okay, so the first thing is that we declare here empty Q. After that, we push, we insert the 5 elements. So the side is a 5. This is the front one is going to be 10. And then the back one or rear one is going to be the 50, the last one you enter. Then after that, you are going to list all the Q elements. Then after that, you pop in there, you will be deleting one by one. Okay, after you, I mean, list the elements in the Q. Then the size after deleting, after the pop, the size will be 0. Okay, there is empty already. Q is empty, no more. Okay, so try to run. What is this? What kind of error? Sometimes more error. Right here. What is this? Oh, maybe this one I have to change here. Because sometimes if you copy from the slide, it might not work. I think. You say after the printing elements. Why it is in here? This is wrong. Okay, let's see. Because now it's a green color. I hope it is okay. Okay, now it's okay. Okay, so see, we have here 5. Front elements is a 10. The last one is the 50. And Q elements are the 10 first, because 10 is in the first, 10 second, and then 50 will be the last. And Q side after printing the elements is going to be the 0. Okay, because after printing they remove, because the word there is a pop here. Pop means that they are going to take away or delete away. Okay, so this is the automatically result. Sometimes if you copy from the slide, if it might not work, then you have to change something. Okay, so try to find out, okay, the errors, so it will be good for you, okay, how to fix everything. Okay, so please try to understand, okay, stack and queue. Okay, so I give you only very simple proof. Okay, so in the exam, the output will be modified, and then you have to change the coding a little bit. Okay, that's it. Thank you.